with this programming example, I'm going to initialize an one-dimensional array with n randomly generated integers. Then we will be finding the sum of these elements and the average as well. So first of all, we need to take the value for n from the keyboard. For that, I have already written the code, the printf to prompt and scanf to take the value into n. Now we need to declare the array of size n. So declare the array. Now that's the comment. Okay, so we have declared the array with n elements. Now next we need to generate n random numbers and assign them to the corresponding elements of the array. That means the first random number is to be assigned to the first element, second to the second element, and so on. You know that for using rand function, in order to get the random numbers, we need to initialize the seed with the time value of the system, so that on each execution the rand function is going to generate different set of random numbers. So I am calling the srand function and passing the time in order to initialize the seed with the system time. Now in order to use srand and rand, we need to include the header stdlib.h, and for time we need to include time.h. Now if you don't know about these random numbers, how the rand function generates random numbers, how to initialize the seed using srand and passing time, all these things, don't worry, just go through the tutorial that deals with all these things named random number in the same course. I have already given them in the course, so you can just go through that tutorial and can get all these details. Okay, so going ahead, I'm just writing a for loop in order to generate the random number and assign them to the corresponding elements of the array. So here the for loop goes. It starts from I equals to 0 because the index of the first element is 0. So xi is the ith element. That means for the first time x0 is the first element. So I'm calling the rand function to get the random number. Let it be only 2-digit random number. So I'm just applying the modulo operation with 100. That means the result is going to be from 0 to 99. Okay, so this is going to initialize the array with random numbers. Let me just print the content of the array which we have just initialized with randomly generated integers. Again, in order to print the content of the array, what I need to do is to write a for loop that will iterate through the array elements, and from I equals to 0 to I less than n, each time I is going to be incremented by 1, and I'm printing the content here. Okay, by mentioning 4 here with %d, we are actually mentioning the width of the number in which the number is going to be printed in the output console. That means while printing the number, it's going to reserve 4 characters dedicated for this number, and the number is going to be printed right aligned. So each number is going to be printed on 4 character columns. So the alignment is going to be perfect in that case. So let me just execute and show you how it goes. Here I'm executing the program. First of all, it is asking for the number of elements. I'm giving 5. So here you go. There are 5 numbers. Now if I execute once more, I'm giving 15. So these are the 15 numbers. You can see that I have mentioned %4d, so it's always 4 characters here, and the 8 is printed right aligned amongst these 4 characters. Again, you can see that it's 4 characters again. So the gap between them is between the number is always perfect. Okay, now we need to find out the sum of the elements in order to find out the average of the elements. So I'm declaring a variable sum, and I'm initializing this with 0 in order to do away with the garbages, because any variable declared within a function by default contains garbage. So sum equals to sum plus xi. So immediately after printing the ith element, what we are doing, we are accumulating the ith element of the x array with the sum variable. So initially the sum was 0, then x0 will be added, then with that x1 will be added, and so on. It will go up to n-1th element, that means the last element. Now when we come out of this for loop, the sum is going to contain the summation of all these elements in the array. So sum is %d, and we are printing sum. So now if I go on executing this, first of all 10 elements are going to be allocated. We should have given a new line here. You can see that. Anyway, the output is this. These are the 10 random numbers generated into the array, and then the sum of these number is 417. Let me just give a new line here before printing sum. It should be on the next line. Okay, now I'm executing once more. You can see that. So I'm giving 15. So these are the 15 numbers that is generated by the rand function and assigned to the array elements, and this is the sum of all those 15 numbers. Now I need to find out the average of these numbers. So I'm declaring a double variable, and the name for this is average. So average is going to be sum divided by the number of elements, that is n. Now this is not going to get us the accurate result because sum is integer, n is integer, so integer divided by integer is going to be integer. So if the result is having a decimal precision, then that's going to be truncated. So what we need to do, we need to cast it. Now again, as a note, I have already discussed why this type casting is required and how this can be done in an earlier tutorial. You can just go through that if you don't understand anything about typecasting. Basically it's simple. It is, before applying the content of sum in this division operation, I'm forcefully giving the instruction to the compiler to convert the content of sum to double. So now the operation is between a double value and integer value, so the result is going to be in double value because double is having higher precedence. So the result is going to be accurate in this case. So average of the numbers %lf, and %lf is the format specifier for double, and I'm printing the average. Okay, it's done. So I'm executing the program. Here we go. It's asking for the number of elements. I'm giving 10. You can see that the sum is 600. These are the 10 random numbers generated into the array, and this is the average. I'm executing once more. Now I'm giving 25. These are the 25 random numbers. It's 888 is the total of these numbers, and this is the average. You can see that here we have these decimal points. Had you not imposed this casting, this decimal accuracy would have been truncated.